Welcome back to the discussion and thank you for always joining us. This is K.c.s.e 2002 paper 2 question number 24, a question on differentiation. And the first question we have reads, the displacement s meters of a particle moving along a straight line after t seconds is given by s is equal to 3t plus 3 over 2t squared minus 3 minus 2t cubed. Part A, find its initial acceleration. Remember, given the displacement, we differentiate displacement to get velocity, and you differentiate velocity to get acceleration. In this case, since we have the displacement function and we need acceleration, we are going to differentiate 2 times for us to get to the acceleration function, because the first differentiation is going to give us velocity and then the second one will give us acceleration. In this case, we know velocity is given by ds over dt, and this one is going to give us, you differentiate 3t, you simply get 3, plus you differentiate 3 over 2t squared, you simply multiply 2 down here, then you go and less 1 from the power. We are going to remain with 3t, and minus 2t cubed will give us minus 6t squared. That is our first differential function of s. Then now to get acceleration, we are simply going to differentiate velocity in respect to change in time, and this one is going to give us, we are now going to start with 3t. You differentiate 3t, you get 3. Then you differentiate minus 6t squared, you bring down 2. This gives us minus 12t. And remember that at initial acceleration, the value of t is 0. At initial acceleration, the value of t is usually 0, and therefore we are going to have 3 minus 12 times t, which is 0. This one is going to give us 3 minus 0, which is going to give us 3 meters per second squared as the initial acceleration. Once we have obtained the initial acceleration, we move to part B, where we are supposed to calculate the time when the particle is momentarily at rest. And we know at rest, the velocity is 0, or the body has 0 velocity. So what we are going to do, we are going to take the velocity function, which is 3 plus 3t minus 6t squared, then equate to 0. We are going to reorganize our equation. We begin with the term that is squared, then we go to the term that has t, and lastly the constant. If you divide all through by -3, we are going to have 2t squared. 3 positive divided by -3, you get -t. Positive 3 divided by -3, you get -1. And this one is going to be equal to 0. This is quadratic. We use product sum factor method. Product is the first term times the last one. This one is going to give us -2, and the sum is going to be equal to the coefficient of the linear term. So the two factors are -2 and 1. After we have done that, we rewrite the quadratic equation. We are going to have 2t squared. Instead of the linear term, we use the two factors, that is minus 2t plus t, and of course minus 1 is equals to 0. We are going now to factorize the 2 in pairs between 2t squared and 2t. 2t is common into t minus 1. Again, we are going to have t minus 1, and the common factor between t and minus 1 is going to be equal to 1. Once we have done that, we are going to have 2t plus 1, the ones outside the bracket, and of course we pick one of the brackets since they are the same. From there we know 2t plus 1 is equals to 0. Then 2t is equals to negative 1. You divide both sides by 2t is going to be equal to negative a half. Also, we can say t minus 1 is equals to 0. Therefore, t is going to be equal to positive 1. Since time cannot be negative, we are going to disregard the negative value for t, then conclude and say the value of t is going to be equal to 1 second. Once we have done that, we can now go and square Roman 2 of part B. Remember what we have done is Roman 1. Then B Roman 2, we are supposed to find the displacement by the time it comes to rest momentarily. For us to get the displacement, we are simply going to substitute the value of t, which is 1. So our displacement function is 3t plus 3 over 2 t squared minus 2t cubed. And when t is 1, we are going to have 3 multiplied by 1 plus 3 over 2 multiplied by the value of t, which is 1 but squared, minus 2 times the value of t is 1, but this one is cubed. 3 times 1 you get 3. Then 2 over 3, that 3 over 2 times 1 will give us 3 over 2. And of course, minus 2 times 1 cubed will give us minus 2. This one is going to give us 2, that is 3 minus 2 will give us 1. Remember 1 plus 3 over 2 will give us 2.5 meters as the displacement of the particle when it comes to rest momentarily. Next, we are going to move to part C. And in part C, we are supposed to calculate the maximum speed attained. And we know at maximum speed, acceleration is usually equal to 0. So what we are going to do, we are going to take the acceleration function, which is 3 minus 12t, and equate it to 0. If you take minus 12t to the other side, we are simply going to have 12t being equal to 3. Divide by 12 on both sides. 12 and 12 will cancel. That means the value of t is going to be a quarter. Once we have gotten the value of t, we can now get the maximum speed by simply replacing the value of t that we have gotten back into the velocity function. Remember, the velocity function is 3 plus 3t minus 6t squared, but the value of t is a quarter, and therefore the velocity in this case is going to be equal to 3 plus 3 times t, which is a quarter, minus 6 into a quarter, but this a quarter is going to be squared. And if you make use of the calculator, the value of v is going to be 3 and 3 over 8 meters per second as the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, Please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.